The rhenium is in a sea of chromic, in the chromic sulfuric, and there's two problems. Is you cannot dry sulfuric acid down, and you have all this chromic. So we could never load this solution on the mass spectrometer. It would just be impossible to get a measurement off it. So we have to separate the rhenium from the sulfuric and from the chromic. And we'll do that with an anion exchange resin or cation exchange resin in the next step. So what we've prepared now is a way to separate the rhenium from the chromic and sulfuric. And what I'm holding in my hand is a little teflon paddle, if you will, with a column. A column is like a little syringe body. We've got it neck down at the tip. I filled it with a little bit of Teflon wool, and I put this beige colored powder in there. It's actually plastic balls of polystyrene, and it's called anion resin, and it's typically what you have in your Brita filter. So you can think of this as kind of a Brita filter for separating rhenium. Just like in your Brita filter, you want the Brita filter to keep back lead and other constituents that you don't want to drink. When we put the rhenium on this column, the anion resin will keep back the rhenium, and then it will let everything else flow through, the chromium and the sulfuric. And then we'll wash the resin that has the rhenium stuck to it with other acids to kind of clean off all the residue of the chromic sulfuric. And then we'll change the acid type that's on the column, and when that change occurs, the rhenium will be released by the resin, and then we can collect the rhenium drops that will be concentrated in the drops of acid that come out at that point. And the acid that takes it off is a nitric acid. So we have a column holder, so we can do multiple samples at one time. That's in here. And so I would have this particular sample labeled in spot 1, and I would have samples all the way around the carousel, and I would be separating all the rhenium at one time from 12 samples, again in this nice clean environment where we wouldn't have any contamination. And again, like any chemistry, this looks like it's very low tech, but it's low tech on purpose, because the simpler the apparatus and the simpler the glassware and the plasticware, the less contamination you have. And so we do this since we're doing very small inclusions, and we're doing, rhenium is not there at any level above the part per billion level, we have to do it in a very clean microenvironment, and as well as doing it with simple apparatus that can be cleaned up. Once we collect the sample in a beaker, we'll collect it in a Teflon beaker that looks like this, a good Teflon beaker. This is just collecting the waste acid. So when it's time to collect our rhenium, we'll move the beaker, change it like this, start collecting the drops. Start collecting the drops into a good beaker that we can dry it down in. And then once we've collected about an ml of this solution, we'll dry it down and it'll be ready for mass spectrometry for the rhenium analysis.